In Chapter 10, we're going to be going over conic sections, which are sections that you can get from slicing cones. And I just want to show you the different conic sections we'll be going over. If you slice horizontal, you're going to get a circle. If you slice on a diagonal, you're going to get a parabola. If you go all the way through to the bottom here, if you slice on a diagonal just from side to side, you're going to get an ellipse. And if you slice perpendicular to this here, you're going to get a hyperbola, which has two branches. So we're going to start with the circle today, and it's the most easy conic circle, or sorry, conic section. And what I want you to be able to do is write an equation for a circle and a tangent line to the circle. And to graph a circle, identify its center and its radius. So let's just define a circle. It's a set of points in a plane that are a fixed distance, called the radius, from a fixed point called the center. Now, because of this, we're talking distance. The equation of a circle is derived from the distance formula. Okay, and I just want you to write down the distance formula because you'll be using it quite a bit in Chapter 10. The distance formula, when you have 2 points, this is our first point, and these subscripts just represent that this is from the first point, the x and the y, and these are the x and the y from the second point. So when we use the distance formula, we subtract the x's, square them, and add them to the y squared, or the difference of the y squared. So just make sure that if you start with the second point for the x, you have to start with the second point for the y. Don't flip-flop these or you're not going to get the correct answer. Now the distance formula comes from the Pythagorean theorem. So this would be your a squared, this would be your b squared, and you would end up with c squared because you would have, you're actually finding the distance between 2 points. So you would end up with c squared, but you don't want c squared, you just want the length of that. So that's why it just is d, because we took the square root of c squared. Okay, here is your basic equation for your circle, and the center is at HK. So when you look here, your center would be at 5, -2. And then remember that this represents your radius squared, so your radius would be 8. Okay, let's write the equation of a circle. We're going to be given a couple of different things in order to write the equation of the circle. The first one's pretty straightforward. If you're given the center and the radius, you just go back up here to the equation of a circle, and we take the center, and this is minus, so we have to take the opposite. So if this says -3, we change it, it's minus a -3. So it's x plus 3 squared plus y minus 4 equals our radius squared. So that would be 36. Okay, the second example is when you are given a figure, or actually a diagram, a graph of a circle. We just need to find the center. So this graph has a scale of 2. So this would be 2, 1 for our center. And then if we count here, that's 2, 4, and then 5. Our radius is 5. Now we'll write the equation for that circle. So now we're back to here after we've identified the center and the radius. So that's going to be x minus 2 squared plus y minus 1 squared equals 25. Okay, now we're going to have the center at 4, -1, and we're going to know that there's a point on the circle which is 5, -1. Now, a lot of times in Chapter 10, it's going to really help for you to draw a picture. So what we're going to do is just draw a picture there with a circle. We have our center at -4, 1, and we have a point on the circle at 5, -1. Now remember what we need. We need the center and the radius. Well, we know the center is right here, and the radius goes from the center to a point on the circle. So if we can find the length of this, we'll have our radius. Well, the length can be found by using the distance formula. So we have these 2 points. We have 5, -1. I just put the second point first, and 4, -1. So we can take the x's, and if you line them up like this, sometimes it helps you to keep from subtracting an x and a y. So we'll do x2 x sub 2 minus x sub 1, so negative 4 minus 5 plus 1 minus a negative 1, and that gets squared. They're both squared here. The differences are squared. So that's going to give us a negative 9 squared plus 2 squared. We have to take the square root of that. And that's going to leave us with the square root of 85, which is r. Now we don't want to take the square root of 85 because remember in the equation for a circle we square the radius. So now we have the center, which is at negative 4, 1. We can write the equation x plus 4, since this is a plus 1, we're going to subtract 1 squared, and we're going to square this radius, so we'll just leave it at 85. Okay, now we want to see if a point lies within a circle. So here is a problem. We have a diagram here that it's a map. It shows a 3-mile delivery area for a pizza company, and let's just say they decide they want to increase their delivery area to 4 miles, and we want to know which houses are located within that area. So what we want to find is the points that are inside the circle. So if we write the equation for a circle, then we can just, instead of saying, well, let's see, our center is at 1 or negative 1, 2, so we have x plus 1 squared plus y minus 4, y minus 2 squared, and since our delivery area is 4 miles, 4 squared is 16. So we want to be either on that circle with a radius of 4 or inside of it. So we just say less than or equal to. Now, sometimes it's really easy to tell. We can tell that one is not going to be in the 4-mile delivery area. Now, remember, this one's the 3. We're increasing it to 4. So what you do is you just take the points that are close. We'll look at A and E. And A is at 2, 4. So we'll do 2, 4, and we'll just substitute that 2 here and the 4 here, and ask ourselves, is that less than or equal to 16? Because that will put us inside the circle. So we'll get 3 squared plus 2 squared, and we want to know if that's less than or equal to 16. And it is. It would be 13. So A is inside the circle. And then if we check for E, E has the coordinates of 1, negative 2. So we'll go back up to this equation for the circle again and see if we're within 16. So that's going to be 1 plus 1, we square that. Negative 2 minus 2, we square that. We need to know if that's less than or equal to 16. Well, that one turns out not to be because this would be 20, so that one is no. So the points that are within our 4-mile delivery would be A, B, C, and D. Okay, now we are going to write the equation of a tangent line. This is the last example that we're going to do. And we have, we want to write the equation for a tangent line to a circle that is x squared plus y squared equals 29 at the point 2, 5. Now, again, draw a picture and you can see what's happening here. We have a circle with a center at 0, 0, because this is like this would be like x minus 0 squared, so that's why we're at 0, 0. And the radius is radius squared is 29, and it's going to be tangent at the point 2, 5. So a line that's tangent to a circle just intersects it in one place. So we draw a diagram and identify the center of the circle, and we know that's 0, 0. We find the slope of the radius at the point of tangency. And the reason why, remember we're writing a line here, so we need y equals mx plus b. So we need a slope and we also need the y-intercept. And here's our line. We don't have either one of those. So if we find the slope of the radius at the point of tangency, we'll be okay. Because if you remember that when a tangent line, this is from geometry last year, when a tangent line intersects the radius of a circle, they intersect at a 90-degree angle. So I just put a right angle here. That means they're perpendicular. So what do we know about lines that are perpendicular from earlier in the year? Lines that are perpendicular have slopes that are negative reciprocals. So if we can find the slope of this line, we just have to take the negative reciprocal and we'll have the slope of that one. So that'll help us out a lot. Okay, so we're going to use the slope and the point of tangency to write the equation of the tangent line. Now, the reason why we're not going to use the why we're going to use this point instead of this point is because this point's not even, the center's not even on the line. So don't use this one. After you find the slope, then just cross that one off. Sometimes students will use the center to write the equation for this line. And that, if you think about it, that doesn't make sense. 0, 0 is not on that line. Okay, so you can use slope-intercept or you can use point-slope, and I don't care which form you use. We're going to use the slope-intercept form first here. I have 2 points. I need to find the slope. So we want to find the slope of the radius at the point of tangency. So we have 0, 0, and 2, 5. So I'm going to take 5 minus 0. Y's are in the numerator, x's are in the denominator. So our slope is 5/2 for this radius, but we want the slope of this point, the tangent line, so we have to take the negative reciprocal. We want the perpendicular slope, which is negative 2/5. Okay, so now we say y equals mx plus b, and then we can put our points in, x and y, or put our point in. So this is our y. Remember, we do not use this point because that's the center of the circle. We want the point that's on the line. So 5 gets substituted for y, and then we have our slope, which is negative 2/5. X is 2, and then we need to find the y-intercept. So when we do that, we end up with b equals 5 4/5 or 29/5. And then you can write the equation for the line, y equals negative 2/5 x plus 29/5. If you want to go to slope-intercept form, after you find the slope of the tangent line, which is negative 2/5, you can just substitute that into, remember it's, whoops, y minus y sub 1 equals m times x minus x sub 1. Okay, so our point is xy, which was 2, 5. So we put the 5 minus 5 here, the minus 2 here. And then you can just simplify. We distribute this out to get a negative 2/5 x. We have a negative and negative here. That'll give us a plus 4/5. Adding 5 to both sides, we end up with y equals negative 2/5 x plus 29/5. Okay, and then you have a couple of questions to try.